I would like move one set down so it has room. But yeah, that's just something I have to deal with, I guess.
Mine, I can show you guys later tonight once I get off of work and back from Panda. I can chuck it at the ground and I don't think it'll come apart, and I can still like take it off. But yeah, flex. I can flex it. I'm kidding. But yeah, it's okay.
So back to the coupler.
I extrude it just a certain length. Typically, I don't know if it's just a rule of thumb that I follow, but I make this about 1/4 inch in thickness, and I make the bottom a little bit thicker. I'll show the section view again. Just because I have in my coupler, at least, I have 2 U-bolts because I'm doing a dual deploy. So I have shot cord running through here, and then more coming out this end. So that was something I considered back out of that. And then I also added a fillet just because of stress concentration and stuff. I didn't want the bottom of my coupler just rip out. And then the other thing that I included were epoxy rings. So the way that I am planning on putting this in my rock is I'm going to fill this all up with epoxy, shove it into the upper half so it's fixed in there. Because if you don't include these epoxy rings, then it's just going to shove all the epoxy out because there's no room between the actual coupler and the body tube. So that's just a way that you can include more epoxy and you have like a better grip. If you go with, I guess, a commercial method, their couplers actually aren't attached to any of the aren't permanently attached to any of the any parts of the rocket, and they're just attached through shot cord. But I guess to show how these epoxy rings work is I basically just made a half circle through here and then revolved it around the entire thing. That's what this axis is for. And then since you want basically half of your coupler to be in the upper half and the other half to be in the bottom half, I basically just linear pattern this all the way up to so total length is 6 inches. I just linear patterned it up to 3 inches. And then if you're including U-bolts, which is the way I went, you could also do an I-bolt, I think is also sufficient. I just found the I-bolt I wanted to use, or the U-bolt I wanted to use on McMaster, and just threw in some holes and basically made sure it fit their dimensions that they put in. So that's pretty much my coupler that I designed. You could also just make one singular hole here, or there's a lot of flexibility that you can go with. Do we have any questions?
And again, for perspective, if you then if you go for like the coupler, like we said, with just buying like the tube that's already specified for like fitting inside the other body tubes, then slapping on each end, you would just need a bulkhead, and like the bulkhead would just be like a plywood disc that you also make sure the holes get cut in like the same size as like if you're using a U-bolt, an I-bolt, whatever. You just need good, and you don't even have to get the holes laser cut through the bulkheads. You could just go grab a power drill and choo-choo.
Well, I don't know. Plywood I don't like drilling through because it splinters.
Frick. Well, and I also guess if anybody wants to, I guess you could also go ahead and build a fully 3D printed like Bay coupler thing. But I
that's
think
also a possibility.
Right, but I don't know if being too thick would, or like the edges being too thick would probably mess with how much space you have. Like the benefit of like those couplers that you can just get from Apogee that are already like the right size. I mean, it's also cardboard. You can like break them with your hands, but still cheaper. You don't have to wait like a couple hours for it to 3D print from somebody else. Like actually, well, I guess the 3D print might actually be cheaper when you have a really thin wall like that. But I think the
after I'm done, I can show like my planned Ave, because I did like I basically just made a sled out of plywood and then epoxied it together. But
And if you see any of the listings on Apogee sells like pre-made couplers that I think are way too overpriced.
Yeah.
That I mean, not couplers, Av bays that have like all this stuff. You can make all, and that's I made my design based off of one of the other things on Apogee. So
like I'm looking at the website right now for a 2.6-inch Av bay. It's $32, which is like probably triple the price in like materials if you just do it yourself.
More than that, barf.
Probably, yeah. So, you know, practice your design skills. Make it your own. Is my suggestion, but if you want to go the pre-made route, is also completely valid. If there's no questions, that pretty much ends my part.
I'm sorry, I had a quick question to Ian.
What's up?
McMaster, why'd you go to McMaster? It's just a general website
I just
that you
love
can go to check tolerance.
McMaster. Yeah, so no. So McMaster sells a whole bunch of different components. They sell anything from like U-bolts to entire toilets, and like they ship it to you super quickly. It's just it's where I got this U-bolt and a whole bunch of different stuff. And I don't know, I guess their quality assurance is really good. I've had really good experiences with McMaster. Their shipping can be a little expensive, but that's like one of my only complaints. Plus, what they also have is SolidWorks files of like pretty much every single component. So if you're trying to make sure that, hey, I'm not sure if my U-bolt fits in this hole, you can just make an assembly and verify it through there.
Okay, awesome, man.
Yeah,
Thank you.
So McMaster, I'll shill for McMaster any day.
Yeah, I also sent a... Oh, sorry, go Nick.
Once more. Okay, yes. Just once more, keep in mind the tolerances when you're making these, right? Yeah, you know, like a normal like rule of thumb is just to subtract 0.2 millimeters from whatever your diameter, for example, right? You can easily do that in SolidWorks. For example, if you're in inches, right? Just specify, all right, like 4 inches minus 0.2 millimeters, and that should give you like a good kind of round off of where your diameter should be to account for expansion when you 3D print these parts, right? All right, go ahead, Drew.
So 2 things. So you can decide to go kind of go with the format of the AvBay as like can be seen in Apogee site, and that works well. You could also kind of go wild and do whatever you want and figure out a different way to do an AvBay. The thing I posted in level 2 chat is also a potential way that you could do it. One other thing I wanted to mention is if you decide to fully 3D print your AvBay, you will have to, or maybe you don't have to, but you should include holes for the altimeters to kind of get actual barometer readings of the environment. We could also drill it into the AvBay like afterwards, but if you're already 3D printing it, might as well put the holes in there where they're supposed to be.
Yeah. Are there any questions? I can throw it on over to whoever. Wait, we're doing what? Fins and composites next? Yeah. And throw it back over to you guys if there's no other questions. No? Alright, cool. I'm gonna stop sharing my screen now.
Actually, I think that, Keen, if you do want to share your screen, only because we're going to go into Open Rocket designs, and I think you're going to show one of yours, and then Jake and everyone else.
Right. So I don't have Open Rocket on my desktop. Okay, I'll just have to switch to my laptop. That's where my stuff is. But I'm gonna run downstairs real quick and grab a drink in my my Avionics Bay. So.
Sounds good. Could you go back one slide, Peter? All right, there we go. So before we go into this, you know, I know that we did have a few more people who joined. So there are 2 options when launching your level 2. The first option is launching at Springfest, so on March, 19th through 21st, where the second option is April 17th. And the reason for that is that, you know, some of your items, some of your motors might be cheaper at Springfest. So if you do want to bring down the cost of your level 2, you might want to hold out and buy your materials at Springfest and go ahead and launch at on April 17th. So that's really up to you. Whatever you decide, though, please go ahead and specify that in the Google Forms that I sent in the level 2 workshop. I'll resend it right now, just so we can get a better head count on what we need to get done, especially for composites. So kind of going more into this, we have used composites for our fins in 2 of our past projects. So the first was USRC, that was a 2-stage rocket, and the other was Spaceport American Cup 2019, where we had a 3 printed core, and then we did about, like, I don't know if it was 2 or 3 ply for the carbon fiber. So we have been doing this before, and we thought it'd be really cool to show you all how to do some composites. Composites with me and Brandon. But we thought it'd be cool for y'all to incorporate this into your rockets.
Workshop for
But once again, this is totally optional, right? Like, you could literally just launch a rocket with your plywood. You don't have to do composites. But it would be kind of like a cool process. Okay. But unfortunately, because we do have a maximum capacity in the composites lab, we do need to, or we would just ask for your files for the fins, and from there laser cut it for you all, and then do your layup for you. It'll just be easier for us to kind of get everything done. Because the max capacity in the shop is like 4 people for the lab. So like once again, that ties in with the Google Forms, right? So specify.
Yeah. What are we eating?
So we know who we need to contact regarding their fins if they do want to do composites.
No, I want to know what we're eating.
Geometries, cut it out, and we'll do the layup. But so here are the images on the right.
No, can you give me an answer so I know if I need to order food or not?
We did for USRC. So the core was plywood. And I think we only did like maybe 1 or 2 ply. And when I say ply, that just determines like how many layers you're doing, right? So we did just one or 2 ply, so just like 2 layers of carbon fiber. And you can't have like different geometries, or not geometries, but different patterns for your composites, and that'll kind of dictate your properties. But I think what we have in the shop is 2x2 twill, and that should be good enough for your level 2s. The basic process for this is the just get your bagging ready. And so you see like a yellowish kind of bagging plastic. And so we would first prep that, get it to size, whatever size we need. We'll lay that on the table, tape it down. From there, we put our putty on, kind of creasing, where we're going to flip that, plastic over. It's kind of hard to talk about it when it's not in person. It's a lot easier to visualize when we're actually in person. And we will be filming this process when we do your guys' fins. But yeah, I mean, after you get your plastic ready, put your putty down. The longest part of composites is the prep time, right? So you do have to prep your cotton, your Teflon, your composite material, right? So you're using fiberglass.
I wasn't joking.
Using, Kevlar. We usually do just go with carbon fiber, and that can also be used for reducing flutter in your fins, right? If you do need to increase the stiffness, you get like a specific stiffness of your composite based on maybe your ratios of your whatever epoxy you use and whatnot. But the process that we do use to cure these is a vacuum pull. So we're basically just vacuum bagging the entire composite, and that's where you see on the bottom right image where a hose is kind of attached to the plastic, and we're sucking all the air out, because you want to pull out all the air, because if you do have air within your composites, you do reduce the strength of your kind of your part in general. And that's why if you see in industry, a lot of these composites, they actually run them through some kind of like laser testing where they identify some air pockets within some composites. For example, for airplane like fuselage or some kind of component, they do need to analyze like how many air pockets are there to make sure that the material is strong enough. But that's basically what we're doing. We're also pulling out a little bit of the epoxy, because once again, there is like a good ratio between the amount of epoxy that's in there and the fibers, right? So like what's dry, but not really dry, but just that ratio of how much epoxy is inside of your composite. I believe the ratio is around like 60-40. But I mean, that's the general process. And I think we usually just leave the pump going. So we're just pulling air from that bag all night, and give it like maybe 24 hours. We should be good to go. And then once we unbag them, you should have your composites ready to be cut to size. Any cutting or any tooling that we do need to do, there's a chop saw in the shop where we just cut off the excess composite material. But once again, if you are planning to do composites, I would highly encourage it. Please fill out the Google form that I put in the Level 2 workshop channel, so we know who we need to contact to kind of prepare and get you all ready for that Spring Fest, launch date. But with that said, Drew, did you have anything to add?
Yeah. So the process we're kind of describing here is doing individual fins or individual components and strengthening them, then like doing epoxy plies on them, or sorry, not epoxy, carbon fiber plies on them to strengthen them. That's a very good way for strengthening individual components, and it's also a method that I think we're better at generally. Another thing I did recently, which might be more helpful, especially if you're deciding to go like a full cardboard build, and you, for example, can't get blue tube or don't have access to blue tube, or you don't want to spend the money on blue tube, or fiberglass for that matter, you could do it looks a little rattier, but it's also very, very strong. An carbon fiber layup on the fin and the body tube at the same time. The downside to this is we can't vacuum bag it nearly as well, or at all. And you kind of have to figure out a different method for applying pressure. The way I used was to just get like a 40-pound sandbag or something similar from either Lowe's or Home Depot or something. You put the ply on, you put a piece of wax paper on it, and then you lay the sandbag on top, and that kind of provides the same pressure differential that that the vacuum bagging process does. Again, it's not going to look quite as nice, especially like surface finish wise, but it will be very, very strong, and it gives the added benefit of you're actually bonding your fins to your body tube, which can be very, very helpful if you're worried about maintaining rigidity of the whole fin can.
Kind of adding to that, so all these composites, it comes at no cost of you all. Dr. O'Toole, our advisor, is in charge of the composites lab, so everything is totally free. That accounts for these carbon fiber. We have different kind of weaves that we have in the shop or in the lab. Additionally, we do have some fiberglass. We have Kevlar, like I mentioned. So this is totally free, but do make sure to fill out that Google form. Let us know who's launching in Springfest, who's going to go for the April launch, just so we're able to kind of gauge who we need to get the geometries for your fins from. But that's about it for fins and composites. Does anyone have any questions? Alrighty, so if we want to move on to the open rocket examples.
Alright. Who wanted to go first?
I have it pulled up if you want to do that.
Yeah, go ahead, because I'd have to switch to my laptop anyways.
Sounds good. Okay.
Yeah, it should be Arshia. I think Drew still has OBS running.
Yep. I still have OBS running.
There was that tiny cut, but
maybe a little bit more of a tiny cut, but yeah, sorry.
Was it really?
Probably like 3 or 4 minutes. Not that bad.
Okay.
Let me know if you see my open rocket screen.
Yep.
Awesome.
Yep, you're good.
I think, yeah, this is the one. Yeah, so as you see, this is actually an L1000. It's probably a little overkill. Can you hear me?
Your
streaming
stop, yeah.
Oh, it stopped streaming?
Yeah.
What? What about now?
Yeah.
Okay, sick. So this is my level 2 scratch build titled Expensive Mistake. Aptly, I think. So as we kind of talked about, it has a lot of the same components in terms of like the positioning of the Avionics Bay. So I have like this center coupler here, and I'd have the blast caps on this side and this side. And as Jake mentioned in the very beginning, I chose to have my drogue on the bottom and my main on top. However, that's totally up to you. As Jake said, there are benefits to switching their position, but due to the fact that I had a streamer for my drogue, which that's mainly for visibility, and that's something also you guys might want to consider, especially if your rockets are going super high. Having a streamer as a drogue allows you to see it from like 2 or 3 miles away very easily. I think my streamer is like 30 feet. Yeah. Do you say something?
Oh no, my bad.
Okay, you're good.
Just wait.
Yep. Yeah, so I mean, I made kind of the same general decisions as we talked about in regards to choosing my nose cone geometry. So because I was kind of going transonic, and I intended to eventually go even faster with an L1000 motor. Here I think I have a K400 simmed. Here it'd be an L1000. I chose the von Karman geometry for the nose cone. Also, some considerations is especially if you want to come in relatively fast for your descent velocity, you might want to consider moving your fins up a little bit. So I also had a minimum diameter rocket, meaning these fins couldn't slot into the actual body tube and be reinforced that way. So for added safety, I kind of moved them 2 centimeters up, so when the rocket kind of falls, the butt would land before any of the fins contact the ground, trying to prevent them from being snapped off and therefore disqualifying my cert flight, which would not be so great. So I also chose to have a bulkhead here, so I kind of limit the motor ejection charge from the get-go. So again, I think Jake mentioned this. It's possible to use your motor as a redundant ejection charge for the altimeter, but I kind of used the bulkhead here and I kind of ixnayed that idea. But it is possible to do. Are there any questions about like why I chose specific things in this design before we move on to the next design?
Yeah, was that just a preference, you choosing a smaller diameter? Or...
Okay. So...
Good question, sorry.
Yep.
Why do you want your stability at 2.76?
Ah, okay, so this is interesting. So some freaky things happen as you get transonic and also as you get to a very long rocket. The longer a rocket gets, the less the 1 to 2 stability margin is what you want to shoot for. The math on this is a little weird, and if anyone has a very long geometry like really long rocket you're designing, I'm happy to help you with it. But I think it's a little bit too complicated to go into tonight specifically. So yeah, so long rockets need a bigger stability factor, and transonic rockets need a bigger stability factor. So like those two design considerations kind of pushed me towards the little bit above 3 margin of stability. If I can actually do a really quick flight sim, what I've been simulating, if I go 10 miles an hour, 108 flight in hurricane, what I've been simulating that I think we might want to consider doing as well is the CP and CG location throughout your flight. So you can actually see, while the rocket is very slow, my CP location is actually below for the first like quarter second of flight. So as long as for the vast majority of your flight, and especially when you're going fast, it's in the right location, as in the CG is like below or forward of CP, you're good. And as you see, for the vast majority of flight, it's not a problem, especially as after I get up to 1 second and once I get up to speed. Sorry, Gennaro, I think I might have skipped over your question. What did you ask again? Why I chose minimum diameter, right?
Yeah, because I was thinking like you may want to leave a little bit more diameter room for the electronics, perhaps. But I guess.
Correct.
I don't know.
You know, that makes a lot of sense. So it's way easier to fit both actual electronics and parachutes and shot cord in a wider rocket. One of my issues is that, like, my parachutes and shot cord barely fit. Is someone echoing a little bit? Okay, it's fine now. So that's one consideration to definitely have. Like, a large rocket just makes it easier, both in terms of operating things inside, like sticking your hand in, clipping things. However, the reason to go for a minimum diameter build is because you're reducing your inherent drag. The smaller your diameter of your rocket, the smaller cross-section you're presenting to the atmosphere, and therefore the higher and faster you can go. My goal of this was transonic and as high as possible. So minimum diameter was kind of an obvious choice. If you want to go high and fast, minimum diameter is always the way you want to go. If you're just trying to make a rocket that's going to cert well, is going to fly well, and it's going to be easy to build and easy to operate, minimum diameter is not not really the best option. But it definitely can be done, and we will help you. So yeah, something like a minimum diameter build, this would be a very good candidate for doing a layup on. It'll make it way stronger.
Drew, so when you're doing a minimum diameter build, how do you keep the motor where it's at? Do you add do you epoxy a ring or center ring up top to kind of stabilize it, or how do you go about it?
Yes, so there are several methods for doing this. One is the good old friction fit, which I think we've been doing on the vast majority of all our rockets. And friction fit is even easier with this specific build because I plugged up this part of the rocket. That means, first of all, there won't be an ejection charge, so there actually won't be a force pushing this motor out of the rocket. Some other options are to do like an end screw, so you kind of screw a little mount over the motor, which works. Another option is if you had a string connected here, like a very thin string, like fishing line. And you moved it, and it would kind of sit flush with the casing, with the motor casing all the way to the end. You can kind of loop it around the motor casing and tie it as well. However, if you're doing a minimum diameter build, friction fit, very good way to go. You're not going to have any problems as long as you do it right. And as I said, we'll help you get it right in terms of making sure it fits well and it's not going to fall out. Yeah, you don't want to brain someone by having like a motor casing falling from like 10,000 feet. Be bad. Anything else?
Just really quick, if you all do want to even add a boat tail to your rocket, that would boost your drag. And that's definitely an option in open rocket. That would be right around where your motor output is.
So
just to reduce that going out of that. I know that if you get kind of worried about circulation, right? Once you're kind of flying and you know you pretty much launch, there will be circulation that occurs after your you know the end of your tube. That's just going to reduce that drag.
So definitely, and you can actually see I think increased my apogee by 100 meters, which is significant. However, if you're doing a boat tail, it is going to change your center of pressure, so it's not something you can decide to add on afterwards. You definitely have to consider it in the build, and it's going to depend on your center of pressure. The thing about boat tails is also it's probably best to make them out of metal. 3D printing it's going to be tough just because like the flamey end is here, and PLA is not so great for that. So it is definitely a consideration.
What kind of metal? Aluminum?
Aluminum would be fine as long as you keep a good spacing between the exhaust plume and the boat tail itself. With PLA, even ambient heat melts it and you get problems. With aluminum, it can deal with the ambient heat as long as it's not directly exposed to the exhaust plume / flame.
I thought the boat tail for the Love Ship was made of ABS though. I know that's a little bit more resilient, but
so
I don't exactly know.
Yeah, so I honestly don't know very much about the Love Ship, but the consideration for the Love Ship is that it also wasn't... Oh, can you hear me? Hello?
Yeah, I can hear you.
Yeah. So I don't know 100% about the love ship. Maybe Nick can correct me. But because it wasn't a minimum diameter build, you could leave a lot more room between like the exhaust plume. Imagine if you had like this 3 inches wider and you had the same diameter motor. The boat tail could be much wider and get much farther from the exhaust plume while still providing a very big benefit. Is that about correct, Nick? From what you remember?
Yeah. So pretty much the boats we did have an ABS boat tail on the love ship. And that pretty much just extruded off the bottom tube. And from there, we actually had the motor output a little further out from the ABS, just so that we're not having like direct contact with those flames. And that gave us the ability to not really melt off when that happened. And plus, you already do have some insulation from your phenolic liners and whatnot when you do use your casings.
Yeah. So
it actually we're still good to go on that rocket.
Yeah, minimum diameter boat tails are much harder, and I'd honestly suggest people stay away from them. It adds a lot of complexity that I think is a little unnecessary, and there's a lot to go wrong with it. Because as Nick said, you can't move the motor and extrude it out the bottom as much, like past the boat tail. So you have to kind of have the plume go through the boat tail, and that introduces a lot of issues potentially if you don't build it right. Even if you do build it right, introduces issues. Yeah, any more questions before we move on to the next build? Okay.
Yeah, let me just switch over to my laptop and I can screen share from there. Just give me like a quick second.
I have to go pick up Nick. See you guys later.
See you later. I like your SolidWorks mask. I just noticed it.
Yeah, we're sponsored by them. I'm joking.
Gotta keep that sponsorship money up.
Can people hear me?
No.
Thank you, Drew. I had to move to my room because dogs be barking. Alright.
Dogs be barking sometimes.
Yeah. Alright. Share screen. Hopefully everyone can see this. Yep.
Yep.
Alright, cool. So this is the Sharpie. I kind of went about it in a similar way that I did my level 1. I just picked a tube diameter and and basically built off of that. I knew I wanted to do a 54 millimeter motor mount just because it opens up, I guess, the range of rockets or the range of motors that I can use a little bit more. And if we wanted to test some of the rocket grains that the SRAD people did, we can throw it in my rocket, or we can throw it in Drew's Nemo. So that's part of the considerations. There's not too much here that's different from one of like the level 1 builds. The only thing I really added was mass components for my Avionics Bay, which is like right here. And this is completely overestimated, like 360 grams, but that's something that I've been changing along as I've been building my rocket. Because here I don't really have like the U-bolts and the epoxy. So as I've been building my rocket, I've been like weighing it and then changing the masses. If you look here, there's like the weight, I guess, symbol, and then the center of gravity symbol. So if I go into here, you can see how I've overridden my actual because OpenRocket will calculate the stuff for you based off of the components that they have or the properties they have in the software. But obviously in the real world it'll be different. So that's what I've been going off of. So what I did for this one is I just took the mass of the stuff after I cut the actual tube and then just put those properties in. So that way when I'm like as I get closer to the final like iteration of my build, I'll have a more accurate thing, and then that'll lead to a better flight, hopefully. But yeah, as you can see here, I have I'm going for dual deploy, which is kind of different, in a kind of different manner from the way that Apogee does it on their website. I'm just popping out the coupler as you would traditionally, and then my drogue is right here. And then when I get to a certain altitude, I think I did like 500, 600 feet, I'll be popping out my main from the nose cone. So that's a little bit different from how Apogee does it. I think they don't epoxy, or they leave their coupler inside, or they don't epoxy, or they don't fix their coupler inside the upper tube. They just leave it as like I guess an Avionics Bay, and then they connect their shock cords to the ends, and then they deploy from there. So you'd be deploying the entire upper tube rather than just the nose cone. So that's the way how I went about it. We can show it in my little photo studio, the Sharpie. Does anyone have questions?
It's so cute.
It is cute. You know, I wish I had access to my camera right now so I could show that it actually looks like a Sharpie and does not need to be super pointy.
It's pointy. It's not pointy enough.
Okay.
Not pointy enough.
Did he just cut out for anyone else?
It needs to be a fine-tipped Sharpie.
Yeah, that's subjectivity. But yeah, I don't know if there's any more questions. This is my Sharpie. Hopefully you will all see it launch in March. I'm just about ready to put in my my motor mount into the bottom of my rocket. So, ciao.
All right. Does anyone have any questions so far? I'm curious on if you all kind of get the process. I know it's mainly just Hassan and Jazz right now. But does that process kind of make sense, or would you all like to see another open rocket example?
That process makes sense, but I have a question. I don't know if it's not related, but it's kind of related. I want to build my level 2 rocket out of a 54 millimeter using a 54 motor, and I was looking at the blue tube that you recommended, right? And I want to print out my own fins. So how would that whole entire thing work? Because it's only 54, but I have to make a cutout to shove the fins in.
Wait.
I don't know if that makes any sense or not.
Or what? So yeah, go.
I was just saying that I'm with him. I was going to ask about how to cut my fins too. I know you said the CNC machine at the machine shop, but it definitely helped to have kind of an idea of how to go about asking.
Yeah, so I mean, if I understand your question correctly, Jess, you're worried about like minimum diameter. Do you want to put a 54 millimeter motor in the 54 millimeter tube?
Yeah, no, that's what I want to do, right? But since I'm printing out my own fins, don't I have to like make a rectangular cut to shove the fins in and then epoxy it? But wouldn't that interfere with the 54 millimeter motor?
Correct. So what you want to do is what you're trying to do is make a minimum diameter motor. So I'll bring up expensive mistake again. Give me 1 second. Boom. So yeah, what you're trying to do is a minimum diameter motor, and that means you're gonna have to have surface mounted fins. Kian, because he's a crazy person, wants to do surface mounted fins despite the fact that he's not doing minimum diameter. The ethics of that are questionable.
What can I say?
Yeah, he likes to live life on the edge. Okay, so
representing the spirit of UNLV.
Yes. So the general process for mounting minimum diameter fins is usually you get a jig, you make a jig. Usually we can laser cut it at the UNLV machine shop. For positioning the fins. I CNC'd mine just because I have a CNC at home, but like you don't need to be anywhere near that fancy. A laser cut slots in like a tube of plywood or a square of plywood work just fine. So once you have that jig, you generally apply a bead of JB weld epoxy to the root of the fin. So this is like the thick edge where it would attach to the body tube, and you position it. Once you get all of the fins attached in the right locations, you could do the fillets as normal. as we kind of learned how to do in the level 1 workshop. However, since these are surface-mounted fins and they're not mounted inside, they're going to be inherently weaker. The two solutions for this are either making the fillets really, really, really beefy, and including things like cut-up carbon fiber in them that kind of create a ghetto composite and help bond to the fin, or we could do the layup thing I talked about before, in that you could do a layup over the whole 2 fins and the body tube at once. And that would bond it to your body tube, and that would also improve strength a lot, despite the fact that you have surface-mounted fins. So there's totally more than one way to go about this. And the way you go about it will determine the material you make your fin cores out of. So I think since you're planning to 3D print yours, Jess, it probably would make a lot of sense to do a layup on it. Just because it'll be way, way, way stronger that way. You don't have to, but...
I was thinking about, since it's going to be a 54 motor,
yep.
I was thinking about printing a 60 mil tube for it, and then that extra 6 is going to be for the fin. Would that be a good idea?
So that's what's called a fin can, a bolt-on fin can. Let me see if I can find some examples online.
Yeah. I know my camera's not as good on my laptop, but this is the fin jig that I made for my crayon. And it's
this is kind of what you're thinking, right?
Right.
Yeah. So this totally works. So Kian, you said you have one to show? Sorry.
No, I was just showing off my fin jig that I made for the fin alignment on my crayon.
Got it.
This is just 3-fin fin jig.
Yep.
I guess it's pretty simple to make. You just make a circle with the diameter of your rocket, and then depending on if you're doing 3 or 4 fins, just basically make slots for it.
You guys have one for 4 fins by chance?
What's up?
You guys have one for 4 fins?
Typically, most of us go for 3 fins. I'm not sure if there's any left over from the level 1 workshop.
4-fin gang.
Yeah, I have one for 4 fins, but it's only for a 54 millimeter diameter tube. Yeah, so I mean, if you're planning on that, you could definitely use it. Mine are also kind of particular because mine is a CNC'd one. It's not like a laser cut one that has you could like move it up and down. So mine's kind of particular to my fin geometry. But as long as you have something ballpark, which you're gonna have if you're going past mock, just because like you want to have it a certain geometry to be mock stable, you should totally be able to use that. I don't see any reason why not.
Cool. Could I ask you guys?
3D printing could be sick, or 3D printing could make a pretty quick jig, I think, too, if we tolerance it right. Yeah.
Totally.
Could I ask you guys about couplers one more time?
Sure. What's up?
So in regards to couplers, how I guess I'm kind of still a little bit confused on how to couple off your main body tube from the other body tube where electronics are going to be. So I'm assuming the process will be something along an ignition charge with a heat shield, protect everything, and then how do you design the coupler so that it smoothly glides, will eject off without losing stability and strength?
Well, part of it depends on like what method you want it to use. I know Apogee, they want or like I guess their guideline for it is making the coupler the Avionics Bay. So that basically is 2 bulkheads and then your electronics in the middle, and then you attach your shock cord on either end of it, and then you also have your blast caps with the black powder inside of there. So that's one way of doing it. The way I'm doing it is I have the I'm doing it to traditional way where you mount your coupler permanently in the top tube, and I have a separate Avionics Bay there, and then I have a blast caps on top of the Avionics Bay, and I have a blast cap on the other side of the coupler. So what was your question again about like the smoothness, I guess?
He's kind of saying the order of it, or he doesn't understand how it. Or are you just saying? What did you mean by blast off? Like, or how it comes off, or glides off smoothly, or what did you say?
like when you like for example, once you reach apogee and you want to deploy your drogue chute, for example, how do you design the coupler in a way where you kind of ensure it'll actually come off without being too loose or too strong? I mean,
oh, I think I get what he means. Okay.
Yeah.
Yeah. So
Okay.
I think shear pins. Go talk about shear pins. You got it.
Yeah, so part of that is testing, and typically the way you, I guess, secure your nose cone, and I guess you also, I think for that one, you also secure your coupler using shear pins, no? Correct me if I'm wrong, Drew.
Yep. So, especially for fiberglass rockets, which I think Hassan wants to build, you can't really friction fit because fiberglass doesn't have any give. That means you pretty much have to use shear pins.
So, typically... yeah, okay, so that does make sense. So rather than permanently mounting the top half of your coupler in the upper tube, you would put in shear pins so that it, upon deployment, I guess, if you're separating your upper and your lower, it only blasts off the upper and lower, and it doesn't also blast off the Avionics Bay and the upper tube, if that makes sense. So, yeah, you'd blast that off at apogee, your drogue would deploy, and then upon reaching an altitude, your ejection charge in the upper half would go off and then blast off your the coupler / Avionics Bay and your upper tube.
So I'm essentially am I gonna be epoxying one side of the coupler, stay rigid on? So actually, could I show you guys my level 2 kind of this sketch on OpenRocket?
Sure. Yeah. Why not?
All right, I'll just share my screen.
Yeah. Plus, it's also a good way to test it on the ground. Just making sure that like the amount of black powder you have is enough to blast off the shear pins or separate your upper and lower tube.
Yeah. So this is just kind of a preliminary sketch. Can you all see my screen?
It's still loading for me.
Yeah, it's loading for me. I know my Wi-Fi is kind of bad in my room, but
Nah, if it's not working for me too, it's Hassan's shitty Wi-Fi. Sorry, Hassan.
Yeah, let me try doing this. Go from my second screen to my main screen. Maybe that might help it.
man, my laptop webcam is so terrible.
Yeah, it is a bit of a potato cam.
Okay.
There we go.
So, essentially, I have a coupler right here between. I have my one long body tube. I'm gonna cut it in half, and then so the motor is gonna be parachute, shock cord, etc. Up here is gonna have all my electronics. Am I gonna be taking this coupler that I have right here and epoxying it to this top part, and then having an ejection charge perhaps on the bottom, or would it make more sense to move this coupler down here and then have the ejection charge be from the top, so that...
Well, do you want to do a dual deploy or a single deploy? Because that's going to depend. If you want to do a... What?
Dual deploy.
So...
I have the up here, from the parachute, a drogue up here, or sorry, the main chute up here. And
okay. So I see... Sorry if you guys getting bad background noise for me? No? Okay. No. I'll assume no. So... A couple things about this rocket. So right now, think about where your altimeter would have to be to reach both blast caps.
Yeah, so it's gonna be somewhere in this top one right here. So I'm assuming I'd have an ignition charge going this way and one going this way.
Okay.
And
as of now, I don't see how you fit a parachute inside of your nose cone. A parachute for a fiberglass rocket, which is going to be fairly heavy, is simply not going to fit inside of your nose cone. Yeah. So the way, let me share my screen for just 1 sec as well. The way we generally do dual deploy is you have this center coupler, and then this tube is a parachute, and this part of the tube is a parachute. And then when it separates, you have this part as one single part, the nose cone, this tube, and then the bottom booster section. So what I'd recommend is you build an Avionics Bay with like a coupler on both ends and a 1-inch section in the middle, or a 1 centimeter section in the middle for your body tube to go over the coupler. If you look at the photo I posted in the level 2 workshop chat, I think that's probably similar to what you want to go for. So yeah, pull up your rocket again, because I had a couple other things that you might want to consider. Does that make sense, though?
Yeah, totally. Actually, a question about that Avionics Bay that you were mentioning. So
yes.
Essentially, you use the Avionics Bay kind of in the center and then couple on both sides of it?
Yep.
Or use that as the coupler?
So the Avionics Bay is the coupler. Okay. Like, I put everything inside the coupler, and then, like, I put a small section in the middle to prevent it from sliding between the two tubes. So again, if you look at the photo, you'll see what I have in that photo is an actual... Yeah, so look at it real quick. Yeah, that one, I have that fiberglass stuff is a coupler, and then I have a 1-inch body tube in the middle, and that prevents it from sliding. So on the outside, yeah, that part, the silver part, that's preventing it from sliding between the two body tubes. You see what I mean? Yeah. And then I have caps on it, but that's easy. The caps I'm not worried about. So go back to your rocket. Some other things that you might want to consider. This is not like a deal breaker, but is going to reduce your chances of certing. You're going both minimum diameter and swept back fins.
Yeah.
This is doable.
Yeah,
this is doable, but they're very, very scary. Your chances are snapping off unless you're coming down at like 10 feet per second are very, very, very high. Yeah. So, yeah, there we go.
This is the fin that broke off. Because I think it was about like this edge that just like hit the ground, and then it was like, oh.
There's no more fin. Yep. No. Yeah, and that ruins a cert.
Yeah.
The thing is, the fins that are swept back just look so much cooler.
It looks awesome, like no doubt about it. But like trying to go for both minimum diameter and swept back is a dangerous game to play.
Even with carbon fiber fins, you think it might snap?
So that would be the only way I would think it's a good idea, is if you decide to do a layup over the whole thing. So not just having carbon fiber plate, but actually doing a layup over it and connecting the fins to the body tube. Otherwise, what I mean is, Jas, do you have any photos of the one I did for you? Can you post that in the level 2 chat real quick?
For the carbon fiber?
Yeah, the carbon fiber. I sent you some photos, right, of like the layup I did.
Remember, like epoxy on phone, new phone, normal photo.
Oh yeah, let me see if I can find it. Give me just 1 second, Hassan, because I definitely have it somewhere.
Hassan, real quick though, like definitely what they're saying is true. Like most certs, I would say they don't get their certs because their fins break off. And I mean, to reduce the risk of you kind of wasting your time and going out there and failing, definitely go for maybe a different, I guess, like fin geometry and whatnot, or just like placement of it. But if you do want to go ahead and have like that swept back kind of fin, you just do need to pay attention to those fillets that you make as well. If you don't want to do a carbon fiber layup on top of that, your fillets better be strong and pretty thick to make sure that those fins don't break off, because eventually, you know, once you do get your rocket back, you just need to make sure that it's ready for flight again.
Yeah.
Yeah.
I see what you guys mean.
One other thing I would note that we didn't actually even really get time to discuss in the workshop is the influence of fin geometry on speed and altitude. While those fins look very, very cool, they are far from the optimal shape in order to hit Mach and to be Mach stable. So one consideration that doesn't come into play unless you're going transonic is something called Finflutter. As you approach the Mach barrier, you'll have differential pressure on either side of the fin, and it'll cause them to oscillate. And the actual shear force of the wind can actually rip your fin off, especially if it's not an optimal geometry. Swept back fins are unfortunately, like, they provide kind of a big cross section for doing that, again, I'm not saying this isn't possible. It's totally possible, but every little thing you're doing like that increases your risk of failing. Especially since you haven't built a rocket of this power before. Kind of pick your battles. Pick one hard thing you want to do, I think, rather than trying to do all at the same time.
I think it'd be safer to go with the kind of thin geometry that you had with your super long one, where it looked more like a trapezoid or rock.
Yeah.
Kind of thing.
So the geometry for that is either delta or clipped delta. Those are the two geometries I'd most highly recommend for transonic flight. Yeah, so you could just look up clipped delta.
Like the ones that you just posted in chat.
Those are not a clip delta. A clip delta is, like, as you said, kind of a trapezoid on either end. This size has a flat end. This one would probably be okay because it's like most of the delta. And because it's like a relatively small rock that has a carbon fiber layup on it. Yeah, so this is what I wanted to mention. If you look at that photo, it's an even sheet of carbon fiber that goes across both fins and the body tube at the same time. So it's connecting literally all of it at the same time, and it increases the strength a ton. Again, it's not going to look quite as clean as doing a layup in the shop with like the vacuum equipment, but if you want strong, this is a decent way to go about it.
Gotcha.
And if you're doing it that way, I'd recommend getting fiberglass cores as opposed to carbon fiber cores.
Really? Why? I thought carbon fiber was stronger than fiberglass.
It is, however, with Finflutter, you actually, to reduce the effect of Finflutter, you want to have different materials that would oscillate at different rates, because they'll kind of cancel each other out. The most optimal thing would be to do like a core of like fiberglass, then do a layer of Kevlar, and then a layer of carbon fiber, then a layer of Kevlar again, then a layer of carbon fiber. That's overkill for the rockets of our size. But choosing to do two different materials helps a lot. Can help a lot. Yep.
Cool. Basically, all my questions.
Awesome. Anything else before we wrap up? This is a very long session.
Yeah.
Okay. Peace out then, guys. Obviously, like, post your questions in the chat and stuff, but...
Oh, actually, one more thing I wanted to ask you guys to do. Would you be able to pin all the relevant stuff we post in the chat so it doesn't get lost and we're trying to get back to it later, like all the relevant, like the parts or any links, etc.?
I'll go ahead and go through that right now.
Cool, thanks. Alright, later, guys.
Yep, later. Have a good night, everybody.
Bye-bye.
Later, everyone. What a successful workshop.
Yeah. Yeah, it was good.
It feels like after you showed off your open rocket stuff, like everyone just dipped.
Yeah, they're like, okay, it's been an hour and a half. Like,
yeah, it makes sense. So.
Yeah, my bad, guys.